Thank you all for joining us today. Erin and I are calling in from Houston and Chicago, and today we're going to talk about some of the work that we have engineered at Walter P. Moore. For those of you that don't know Walter P. Moore, we are an international company of engineers with 21 offices internationally, and we specialize in designing healthcare facilities, airports, schools, and universities, along with sports projects like stadiums, arenas, and performance venues. Today, Erin will share with you all how and why she became an engineer and describe some of the sports work that she has worked on during her career. If you all have any questions during the presentation, please type them into the chat and we'll answer them during our breaks or at the end of the presentation. And with that, I will hand it off to Erin.
Thanks, Ann. Give you a brief overview. I have a bachelor's and a master's from Texas A&M University, and I've been a project manager in the structures group at Walter P. Moore Houston office for 14 years. So I'm a licensed engineer in both Texas and Kentucky. And so I've been the structural engineer of record for over 14, probably closer to 20 projects throughout the state of Texas. But I've worked on projects from all over the US, from California to North Carolina to Kentucky, down in Alabama, and others, Oklahoma. Why I got into engineering. So I got to college. I'm not very good at deciding the answer. What I usually do best at is kind of creating this big list and then start crossing things off. So I knew what I didn't want to go in, what I wanted to be when I went into college. I didn't want to be in the medical profession. I didn't want to be in the retail. I couldn't be financial. I didn't want to be in the education sector. And so I kind of crossed all those out. And so I was really considering either architecture or engineering when I was dividing it, and then looked around, and architects, they drew a lot and they kind of considered things, and then they were the visuals of it. And to me, that was just a little less interesting because I really was focusing on the how it was put together. Like, yeah, you can draw this amazing structure, but how is it actually going to get built? It's anything that you can basically dream up, we've tried to engineer successfully, actually. So some of the stuff that just goes engineering and the amazing things go behind these dreams. I couldn't dream it up, but I can figure out a way to make it happen. So what I'm going to focus on today, so I've run the gamut of designed, worked on structural engineering for hospitals, for office buildings, for commercial, for parks and recreation, for education, K through 12. But what I really have a passion for is the collegiate sports work. And I've worked on multiple different types of collegiate sports, basketball, football, outdoor track, indoor swim and dive. And so that was interesting. Every time I get to do something I haven't done before, it's very interesting. Because you get to, the whole end goal is really design a space that people are going to use and function. So in order to do that, you have to understand what they want to do in the space. And so the architects sit down with all the end users and the coaches and the facilities and to try to really see what the space needs. And then they come up with the design, and we have to engineer around it. And so kind of understand how it all fits together. It's very interesting and exciting to be able to work on these projects. So the first one I think I'm gonna pause right here actually, and just and any of my introduction on where I got, and see if there's any questions that people have now. And then I'm gonna go over kind of two very quick case studies. For the first project I'm going to talk about is the Fertitta Center. It's actually where the University of Houston basketball team plays, who are currently in the Final Four. Go Cougs! They play Saturday at 4:15. So the Hofheinz Pavilion was where the original building was built in the 1970s. It's actually where all the graduations. So my mom went to U of H, my brother went to U of H, my sister-in-law, multiple friends. So I have a history with this building, and this particular building in particular, because that's where all the graduations happened. When I was in 7th grade playing basketball, this is where we went. The coach took us to see a women's basketball game. So I've been in this building. This is where I grew up, and now I'm the structural engineer of record for this amazing transformation, and working with the team there. And it was really cool project. So the first thing that we did in order to make the outside look like this, the original exterior was kind of bland. It was made during a time in architectural history where there really weren't that many windows, and this big solid panels were critical and important. And so it kind of ended up looking maybe like a big mushroom. And so I'm thinking in my head, how do you lift up a building? It's kind of heavy, but hey, you know, I'm game. Let's engineer this. Let's figure it out. So in reality, what these panels are, they're 17 feet deep trusses. So trusses are steel members that kind of work. There's a load path or a bunch of triangles. Get into engineering, very important part of engineering and structural engineering. But they're 60 feet long. And so luckily they're only supporting these exterior panels. They weren't supporting any part of the building. So basically what we had to do is remove 2 of the panels and then create new trusses with the profile of the new exterior skin to try to, and then replace the back with glazing to let this in. So this is how we kind of engineered the solution. So this structurally is how you lift up the building. So that was pretty exciting. And that wasn't all. This was just the tip of the hat of the iceberg. So what we also did, and this is what it looked like. What we also did was a complete renovation of the interior. So this was a $60 million renovation. It caused by a $20 million donation by Tillman Fertitta. And so Turner was the contractor on this project. They did an amazing job. The whole team, this was just a great project to work on. The U of H facilities guys were great to work on, etc. It was just really a transformation. So the original Hofheinz Pavilion was a big oval seating area. So in sports terminology, we call the seating area the bowl because it kind of dips down like a bowl. And so the bowl, so the seats, the really primo seats in basketball are going to be the ones right against mid-court. And those are the ones in an oval, which are actually furthest away. So we had to renovate that. We had to create new seating. We actually built it up with metal studs over the existing concrete seating to get it closer in, to get more seats in there. And then they really didn't have that much premium seating. So what we did is we kind of created a new club underneath it. So this was a rendering from the architect, like I said, AECOM and PGAL. So this was the original seating on the left, where it was just a straight shot of typical seating, and then they have the premium in the background. And then what the new creation was actually building 2 tiers, so it was seating and then a club area, and then we had an elevated space above that club area with a platform and new seating to kind of get closer, but an elevated view, because you know the viewpoint, sometimes being right next to the court is not the best seat in the house. You can see the players, but you can't see the whole, how they interact on the court. And so sometimes people enjoy being elevated closer to the seating. So now these became some of the best seats in the house. So how we did that from a structural standpoint, like I said, they create the dream, we create the reality, was the original seating, like I said, it was just basically poured concrete, stepped concrete on grade, so on dirt. And so we dug out the dirt, we poured a new slab for the club area, we put a new foundation, a new steel column, a new steel structural system above there, and created those new seatings that we built out of things. And so we kind of created, out of the existing bowl, we created a new structural system within the existing building. So it was, the roof was on, everything had to be done in the tight spaces. And it really just transformed the whole arena in what it did. And so it looks completely different. It's the same building, the same skin, the same trusses, but it's almost like a brand new arena, but the same building. So the other thing we had to do is sports lighting is important. So make sure that you have enough lighting to light the players. There's no shadows. Also, they hold events in here. So they want to hold concerts. They want to hold other major events, PBR, professional bull riding. And so they want to be able to kind of show and hang screens. So we created extra beams to hang from. And then we created basically a walkway, a catwalk walkway around up inside the roof trusses to be able to put all these lights and stuff in there. So kind of enhance the Green Bay. They have a really amazing light show now that's supported from these lights in the catwalk to really enhance this game day experience.
So the first question is, did you get to meet Tillman Fertitta?
No, I did not meet him. I saw him. I got to be close to him, but I did not get to meet him. I did get to design the attachments for the statue of Roy Hoffines, so that there's a new Hoffines statue there. I designed the attachment of the Fertitta name to the building, but unfortunately I did not actually get to meet the man.
The next question is, did you get to travel to see the project, and have you seen a game there?
Well, I drove to the arena, which is about 9 minutes from our office. And so I did get to go. And then, so we went to, it was actually the night of our holiday party. And so I was wearing, it was the 1920s holiday party. So I was wearing my flapper dress. And then, so we left a little early and actually went to one of the opening night baseball game. So I was not the most well-dressed, but I was probably the only the flapper style in the audience. But it was amazing. You did get to see the excitement of the crowd. And then to celebrate its opening, I actually took my whole team to see a volleyball game there. It's not just it's not football, it's not baseball. It's actually not just basketball, it's volleyball as well. And so volleyball is actually one of my favorite collegiate sports. I loved going there. I like being able to sit close and see the excitement, and it's going back and forth. And it's a more intimate setting. I'm actually not a huge people person or crowd person, so I like the smaller nature of it. And so being able to see it, and then you see all these like high school girls who were like there to see the players, and they're like, man, this is really such a great place to play volleyball. I want to play there. Yeah, so this is a video of them of the volleyball team seeing their space. And so we actually renovated the volleyball space as part of this arena renovation too. And so that was really exciting. And then you get to see the families of these volleyball players. And so they're in this new exciting space. And it's just, it's a really great feeling to know that you kind of helped make this happen. So,
cool.
Your page.
All right. The next question is, what happens if there's a problem during construction?
You get a phone call. So no, I got a phone call one day, and they're like, we have a column right here. Columns, what supports? And I was like, it's like right here. And they told me where it was on plan. I was like, nope, the existing drawings show no column right there. You're like, well, I'm looking at a column right here. Can we take it out? And I'm like, what? No, hold up. No, taking out existing structure without looking at it. So we went out there and we had to look at it. And then something must have happened during the original construction that they needed this extra column that wasn't documented. So we had to create a new system and a new kind of transfer beam to take this column out, because it was in the middle of the club and it just was in a terrible spot. And so it wasn't going to make the space work. So yes, there are definitely problems during construction. And so engineers, we don't just design the building. We don't just draw papers, neither does the architect. What we do is we build buildings. And so that means designing them, and that means helping the construction team throughout there. Sometimes the architect and the engineer aren't completely coordinated. Sometimes they want to substitute. Sometimes there's an unforeseen condition that they have to deal with. So absolutely, it's critical to keep that communication open throughout construction to make it work.
Okay. How many sports places have you designed?
A lot. So, and I haven't, obviously I say me, but this is a team. So I've worked on a large range of them. From right now, I currently have about 4 or 5 currently under design or construction. But I've done pro baseball, I've done minor league baseball, minor league soccer, pro football, pro basketball. Obviously the ones I've already mentioned. And then one of my first projects was actually college basketball at the Yum Center in Kentucky, Louisville, Kentucky. And that was pretty exciting too. As big as we are in Texas for football, that's a college basketball town and region of the US. So I've done quite a few. My resume is fairly long.
The next question is, how does the floor accommodate a rodeo and basketball?
It's a great question. So rodeos are, and so, yeah, and I didn't mention rodeo, but rodeo is included. So right now I got an arena in Oklahoma that's primarily, or designed an arena in Oklahoma before. And so rodeo is different. One, you have lighting but you asked about the floor. But the floor, like NRG Stadium for the Houston Texans. So basically, the bottom is a concrete floor, and then so you can put in either the wood flooring with the balance for the basketball and the volleyball. Volleyball, I think NCAA just changed its standard, so there's a new actual flooring for volleyball. And so when that happened, we got a call from one of the colleges saying they actually need more space to store the floors, so they can switch them out. And so basically what you're doing is you're pouring, when you have a rodeo, you pour a foot of dirt on the floor. And that's how you manage it. And so when you're designing an arena for a rodeo, you have to deal with all the dirt issues. And so you have to make it durable so that they can power wash it a lot so that you can deal with the dirt.
Okay. Next question is, what's your favorite event to watch in the new arena?
I like volleyball. I mean, like basketball, but some of my coworkers, they played collegiate basketball, and so basketball is really their thing. But like I said, I grew up, one of my favorite sports was either watching women's soccer or volleyball. And so either of those, they don't play soccer in here, but I enjoy volleyball. Would be my favorite sport to watch.
Okay. And then the last question for right now is, have you met any of the players at the stadiums you have designed?
I get to be near them. So I design these things, but I am still on the outside. They're still the superstars, and there's, the background team. So I'm working the background. So I see them, but I've never actually physically, hey, let's go up and meet them. More likely to meet the coaches and such. And the architects usually end up with more of the interaction with those. But I have been, I got called out when I'm looking at a ballpark and the pro athletes are playing down there. And so I'm like, all right, which athlete has like the blonde wife and the dog or something? So, and I'm, you don't interact because they're doing their job, and their job is not to interact with me. I'm not a fan. I'm a worker. So I don't get to meet anybody, but I get to see them practice. And so I got to, I've been in the U of H basketball practice. When they're practicing, I'm walking around, scanning, look at the existing conditions, and they're practicing so I can hear in the background. So it's kind of like a behind the scenes tour, but you still have to remain behind the scenes.
Okay. So that's all the questions we have for right now. So I think you can continue on to the next case study.
All right, sounds good. Okay, let me go back over here. So this one is going to be Kyle Field. So we're going to switch completely topics, and we're going to go to football. So this was a $485 million construction cost. This is for the Texas A&M football team. So football and home games in this particular are a huge economic draw for the region. So allowing the football team to go someplace else to play for a season was just going to be a multi-million-dollar setback. So it was critical that this project was phased so that they can actually play football in between, which caused extreme havoc on the schedule and the design and the construction of it. But we made it work. So what we did is, so this is the football stadium. This is all of it. That's the Aggie band down there. But what the original football stadium was, a three-sided U. So they had the East student side, the West alumni side, and the North side. And so what we did is we added a brand new South side. That's where the scoreboard is. So it's going to be to the left on the page. And then we completely demoed the alumni side and built a new one full of a lot more premium seats. And then we added some all, and then we filled in the corners. So because we were dealing with existing construction, like I said, that phone call, and it's never, I think on this case, like it was actually like, it kind of, they built it a little bit twisting one side as they got in. So as you got higher, the building that you were thinking you were talking about kept getting a little bit further apart. So those are the kind of things you have to incorporate as you're dealing with existing structures. But so this was the project. The architect was Populous, and then the construction, the GC was a joint venture between Manhattan and Vaughan, and ME was the MEP engineer. So this is the sections of the building. So this was from the architectural drawings, from Populous's drawings. And so if you cut the alumni side, the new alumni side down, this is what it would look like. So you can kind of see that they're tucked in premium levels. There's the seating that we have to tuck in. There's a new canopy on the end there's a canopy on the west side and the east side that was primarily to help shade the fans, but as well as redirect their sound back down to the field to really create that atmosphere of loud intensity when the opposing team was playing. And so with all these premium seats, which is really kind of where a lot of the money is made, everyone can just watch the game on their TV at the house. So you really have to try to create new ways to get them into the seats and really new experiences to get them. So this is what the architecture will look like. There's a big open space called the Hall of Champions, a big event space that they rent out and kind of show all of the historic sports figures from Texas A&M. So that in order to span over, but we still had like 5 levels of structure above that. So we had 15 feet deep trusses going over 100 feet to support all that. So this is what I designed. So the architect comes up with that. They kind of put all the levels, and then the structure in order to design it. This is what we come up with. And like I said, it was a large team of people in order to meet the design complexity and the structure to accommodate that. So you can kind of see the opening there. You can see the trusses over it. You can see all the braces and all the members. And so basically, this is what we design. And which you usually don't see because this is the final product from the seats. You can see all the fans. This is the beginning of the game. I actually do have seats up in the upper left-hand corner of the upper deck, but this is kind of what the view is from the outside. So many aspects of this project I can talk about. I can talk about this project for days, but I'm going to talk about just a little bit about the scoreboard. So the scoreboard is like 163 feet. It basically doubled the size that they are. There's may or may not be a lot of ego in collegiate sports, and so whether or not the A&M's primary rivals had a large scoreboard, and so this one had to be bigger. So there's a size requirement for how big this thing needed to be. And so scoreboards are made up of individual panels, of LED panels, and you can kind of replace, I don't know if you've ever seen one that went out, but you kind of just get a black spot of where it comes out at. And so what you have to do is you actually have to design a series of walkways behind it every 10 feet so that you can interact and take the panels if they're not working out. So this is what the inside of the scoreboard looks like. So there's 5 levels of catwalk, and then there's the roof, and then you have to create the structure to actually put the lettering on top of it. Now this scoreboard is just 160 feet long and 40 to 50 feet deep. This is a 3D rendering from Revit of all the steel structure that we kind of designed for it. You can kind of see the seating there. You see the openings in the seating. Those are called vomitories, where you can go back to the concourses and go to the restroom or get your concessions. And so this is a close-up of the scoreboard in reality. It's very high up there. It's definitely got my steps in. I actually had my daughter, my oldest, during this project, and so I will say walking up 9 months pregnant to get to the top of this it's a workout. And then this is the final product. So this is what it looks like. And this is everyone, like I said, just seeing the immensity of it, but then knowing how it is. You can kind of see there's the speakers on either side. So because this was built in phases, between phase 1 and phase 2, the whole sound system wasn't installed yet. And so they had to hang temporary speakers. And so we had 2 telescoping tubes that kind of stuck out to support the speakers. And I will actually say I wasn't the engineer of record for the whole stadium, but I was actually the engineer of record for those little tubes that you see sticking out supporting the thing. So that was my design. That was me, all me. But and then after phase 2 was built, then they telescope in, and then this is a video of the fans basically kind of enjoying it. You kind of see the excitement. And if you've ever been in like the stadium, like I said, I have season tickets, and so the excitement level in when it's close and they're doing things, and then they make the touchdown, and then basically there's just like a giant energy suck, and it just becomes so exciting, and it's the energy pulse is just amazing in the stadium. So just kind of knowing that you're helped design part of that is pretty amazing. And so that's why I like my job. So I'm done. That's
okay. We do have a few more questions, Erin. How long does it take to build these stadiums?
It ranges. So like I said, the Kyle Field was like they were running 24/7. So sometimes what they'll do is they'll run the cranes for the steel, for 8 hours, 12 hours in the day, and then they'll run the cranes for the precast seating, so that to sit on the steel 12 hours at night. So depending on how many crews, this was multi-crew, they made it between 9-month schedules. And they did do some of the exterior work during the actual football season. So, and that's like super, super crazy fast. But if the normal range, if you're working more of a standard 8 to 10 hour day, 6 days a week, can take anywhere between 2 to 4 years.
Okay. Do you prefer indoor or outdoor stadium?
I like indoor. I like arenas, long span arenas. And there's also the hybrid. So Walter P. Moore actually specializes in the retractable roof, which, can be both. So I like the long span roof and the catwalk systems. And so that was actually one of the things I was designing this week on another project. It was just some of the catwalks and the multi-level and kind of talking about how they all perform. So I like indoor for the most part.
Okay. This is a good question. Does the cost vary when making stadiums?
Yes, absolutely. There are chandeliers in Kyle Field, literally. So it really depends on your finishes. So there's the bare bones. So the Houston Dynamo. So that's the soccer. That's kind of like the golden, like for the low cost economic stadium. So what you have is painted block as the exterior, walkways, concourses. It's kind of very basic. So you're just trying to, you find one feature to kind of put your money in. And in case of the Houston Dynamo Stadium, it's going to be the exterior skin. But the interior finishes are pretty bare bones. Whereas in Kyle Field, I think the maximum donation for one of the suites went for $20 million for a 10-year contract. So it's a lot of money, and they're willing to pay for it. And so the dollar per square foot for those types of stadiums can increase a lot. But like I said, there's a range, but there is a minimum in order, and it also can vary by the construction cost and what the economy is doing, et cetera.
Okay. Next question is, other than structural engineers, who else do you work with on stadium projects?
Yeah, so we have the sports architects. So sports architects they're specialty architects. So they're usually firms that just work a lot on sports architects. So they've done these things multiple times. There's a huge group of them in Kansas City. There's a group of them in Dallas and LA. So I work with sports architects, and I really enjoy that they're so knowledgeable about what they do. So I really enjoy working on a really well-functioning team, very competent. But then there's also specialty people, the mechanical engineers that design all the HVAC, so air conditioning and heating. So in order to imagine heating all of this open space, takes a specialty type of design. And so there's the plumbers that have to do, and then the electrical engineers. And because the electrical engineers have to specialize because of all the sports lighting and all the specialty kind of electricity needs for these types of arenas. And so I've worked you end up working with a lot with the same team over and over again, which is nice. They kind of become your friends.
All right, next question. How much does that scoreboard weigh?
I want to say it's only about 10 to 15 pounds per square foot. It's pretty light, and from a weight perspective. The biggest issue is that it's the wind that hits it. It's like a big wind sail. So if you design, what?
Yeah, help PowerPoint as you can see though.
So let me pull up my PowerPoint again, sorry. Sorry guys, there we go. So it's the wind. And so we actually, for these type of structures, if you design the wind just by code, it's usually at much higher wind pressure because codes are typically designed for buildings. And so what we'll do in this particular case is we're actually hire a wind tunnel consultant. And actually we actually ended up with the Kyle Field wind tunnel model. But basically what they do is they build like a small, like the whole thing was about 2.5 feet by 2.5 feet. It was actually done in Europe. We had it shipped over, but it was basically a full-scale model of the stadium, including the scoreboard. And then they run it and they check the wind patterns of the area and they kind of spin it around. But basically, they put it in a wind tunnel. They blow wind on it to see what the different pressures are of the on the areas in question. And so we actually had a wind tunnel. This helps reduce, I think it reduced the amount of wind that we could design for by like 30%. So while it wasn't that heavy, it was the wind that was part of it. And then so the aerodynamics of that was pretty interesting. So there were specialty engineers that, you know, having her explain how the wind kind of thing, how that wind went, and we had the wind tunnel done for the canopies on the two sides as well. That was pretty interesting.
All right. Did you always know you wanted to be an engineer?
Nope. All I knew was I did not want to be a teacher. So my mom taught high school, as did my father-in-law, my stepfather rather. And so I've been grading papers since I was like 12. So I crossed that one off. I'm not the most patient of people. So dealing with, and then when people get sick, they get crabby. I don't really deal with them. So I knew that wasn't necessarily something that I was going to enjoy too much. So like I like solving problems. Like I've kind of always like, you know, playing with Legos and stuff. So I never knew I wanted to be an engineer per se. I didn't, you know, my parents were teachers or in the oil industry. I didn't really know that many engineers. So I didn't really understand exactly what engineers did, but I knew I really liked doing stuff and making stuff and like creating things, and it kind of just like stuck. But no, I went into college as a general studies major. So I figured it out quick, and I'm glad I won. And internships really help you kind of finalize that. But that's one of the things the ACE Mentor program's helpful with, is kind of helping you understand what these things are before you get into college, or so you can kind of have a better idea. So.
Okay. Do scoreboards have any features such as Wi-Fi and Bluetooth?
So the Wi-Fi and Bluetooth isn't. They're usually hard cabled, but Wi-Fi is usually installed around the stadium. So there's like these little panel boxes they put underneath the seats. And then sometimes I know that they attached. So Kyle Field has 51 flags around the perimeter. You saw them in some of the, let me see if, yeah, so these flags you see around there, those represent the soldiers that died in World War II. But anyway, we had to design the flagpole and the connection to the precast. But also during construction, Wi-Fi people came and said, hey, can we add this Wi-Fi panel to the pole? And so we had to check the pole for that. So those little boxes you see on the flags are actually Wi-Fi enabling to help the Wi-Fi system.
Okay. Next question. Do you have any advice for those interested in pursuing engineering?
Yeah, absolutely. Go for it. But you gotta be curious. So like that first question, and I don't want to go scroll through my whole presentation, but the why, and why, if you find yourself asking why they did that. And so like I can even like putting getting a new toy or a new piece of things and trying to figure out like a camera or something, like where would I put the button? You know, making logical sense. And so like I can usually like, hey, oh yeah, there it is. That's where I would have put it too. And sometimes it's totally not there because either I have no idea what I'm doing with the piece of equipment or it wasn't designed correctly. But But yeah, so you got to get the right program, and so you have to being good at math, understanding like basics, and it depends on what type of engineering too. Like when I was in college, physics, and the forces, and when you're going down a hill, there's a force that pulls you down the hill, but then there's a force that pulls you down. That all made sense to me. But then I went into like electronics and the resistance and that little squiggly line, and dude, I was a little bit lost. So I try to stay away from electronics. I'm not like my husband. He's a mechanical engineer. He designs oil tools. He fixes broken appliances in our house, and I stay away from that. But so being an engineer, there's so many different types of engineers, and so when I was trying to figure out which type, the mechanical engineer, like, do I want to design the small little pieces? Like, what interests you? It's really beneficial to go into an engineering field that really interests you, and you have to want it. You have to want to understand it, but you have to kind of want to know how things work. So go for it. Choose the right college for you. Definitely do internships. Internships really help. And then, yeah, go for it.
All right. Next question is, do some of the stadiums that are constructed contribute to the economy of any country?
So let's say any bid. That's an interesting question, but like let's say you have a bid for the World Cup or you have a bid for the Olympics, right? So all of that part is intended to kind of figure out what the contribution to the local. So they usually sell it as that we're going to bring we're going to build these stadiums and you're going to elevate the rest of the surrounding areas to it. So yes, sometimes if you build it, they will come and it works. But you have to have the right economic, you have to have the right system. Sometimes if you build it, they come for a little bit and then they don't come anymore. And so there's a whole like collection of stadiums that kind of outlive their usefulness. So absolutely, like I said, 100,000, the seating capacity of Kyle Field is 102,733. So if you imagine, and then that's just the people in the stands, there's a whole nother large group of people that actually just tailgate in the parking lot. That they don't even come to the game, they just come and tailgate in the parking lot. So it's a huge influx of people who go to they park, they employ, they use law enforcement from all over, all of the people that sell concessions. So it's a great economic boost for the game days. And then there's all the restaurants and the hotels and everything. And so it definitely, it can certainly be a huge economic boost, but it doesn't always work that way. You have to, there's a lot that goes into it to answer that question.
Yeah, I was just going to say, like the Olympics that are coming in LA, they're doing the master plan right now, and they're looking at how they can best reuse the buildings that are already there because, historically they've built these huge developments to accommodate these events, and not always do people continue using the spaces after the event is over. So, all right, one more question, and please continue to ask questions if you have them. Does each sport have its own specialized set of contractors you have to consult during the build, i.e. for b-ball, dirt surface, for rodeo, etc.?
I mean, there's the specialty contractors that build their equipment. I will say that when we worked with the Texas A&M dive facility, the dive coach builds his own platforms, and he actually has a side business where he puts like the coating on the walkway for the divers to walk on as a non-slip surface. So I guess sometimes that when you do so much research for your own, that they really know about it. But yeah, so there's specialty consultants. There's cold consultants, there's the AV lighting consultants, there's food consultants that you consult with to figure out the best concessions and what type of food you want to sell, and in what areas, and whether or not you're going to be cooking the food on site, you're going to be cooking food off site. So you have specialty types of consultants that you use for the overall building. But typically And then different architects will learn. There's a lot of research you can do out there, and you talk to people. So the sports architects really can kind of understand the different types of specialty things that are needed. Because most of the sports architects that then they'll do multiple Major League Baseball ballparks, or so they have things. That's kind of like working in a firm that has a league of experts to kind of fall back on. So there's not, for those kind of things, there's people that specialize in it, but usually they're in-house.
Within each of the architectural firms, you mean? Yeah.
Correct.
Yeah. Okay. All right. There are no other questions, and I think that's the end of the presentation. So unless someone's going to type anything in right now, that concludes our session. So thank you all for joining, and we will be hosting other sessions that are similar to this that will cover other projects and other people that work at Walter P. Moore. So we hope that you join us again.